Viewers, promise made, promise kept. I promised that I will do a video on qualitative analysis, chemistry practical 2026, based on the materials and structures that we are provided with. Now, in this section of chemistry practical, you will be testing for salt, doing salt analysis. You'll be doing what we call it gas evolution, identification of gases. I even a test for ions. This is what we'll be doing here. So it is very important that you pay attention to detail. What are those things that you want you to observe? The color of precipitate formed when certain reagents are adding to a sample, a salt sample. So you know the nature of the precipitate, the color of the precipitate, whether it dissolved in excess, whether it dissolved in drops. Are you following? These are what you should observe under qualitative analysis. Is that clear? Now, in this year 2026 chemistry instruction materials, certain reagents were provided for us, and based on those reagents, we are going to simulate the possible questions that will come in this year's exam. So, but before we do that, I will start with some of the reagents and what you should expect when they are added to a salt sample. Now, the first reagent we are going to start with is what dilute sodium hydroxide. Dilute sodium hydroxide, okay, NaOH. Please don't be perturbed, don't reject, okay. We are going to enter into this aspect of chemistry. I have simulated 3 questions so far for this year's exam, but before you do that, you must understand what you should expect. Is that clear? Okay, if you see, maybe if I add this to this, what I should expect, that's what I want to do now. So please pay attention. Now, sodium hydroxide. What type of ions do we use? Dilute sodium hydroxide to test for. We use dilute sodium hydroxide to test for ions, metallic what? Ions, precisely. Are you following? We use dilute sodium hydroxide to test for what? Metallic what? Ions. What are those metallic ions? They are called cations. Is that clear? Cations are positively charged ions. That is what we use this to test for. So we are going to look at ions, observation in drops, because that's the first thing you do. They will say add this reagent in drops and in excess. Then when you add in drops, what do you observe? In excess, what do you observe? Good. Now, observation in excess. Okay, so starting with, let's say we use the first item. Let's try copper 2+. Okay, in drops, when we add drops of sodium to this, a solution containing this ion, we don't know yet, we want to know. If we add this in drops, okay, to a sample containing this, you will see a blue precipitate. Please note that precipitate is an insoluble material or solute at the base of what a test tube when a reagent is added. I follow. That's a precipitate. Now, the color of the precipitate is blue. Already, I've gotten a clue that we're talking about copper here. Exactly. Blue precipitate. Now, the blue precipitate is insoluble in excess. It is what? Insoluble in what? Excess. Good. Let's look at maybe zinc 2+, another ion. Now, what will be the nature of the precipitate? It is a white precipitate. White precipitate. That is what? Soluble in excess sodium hydroxide. We also have calcium ion, which is what? A white precipitate as well. Okay? If you add it in drops, you see a white precipitate form, powdery form of it, formed at the base of the test tube. Now, it is insoluble in excess, so if they add excess of it, it will still not dissolve. We have aluminium 3+, aluminium ion. Okay? If aluminium ion is in solution, what will be the color of the precipitate? It is what? A white gelatinous precipitate. Please take note. A white gelatinous what? Precipitate will be formed. Good. Now, it is what? Soluble in excess. Then we have lead 2+. Lead 2+ is white precipitate. It is what? Soluble in excess. Please, if you see ammonium ion in solution, if this is a solution, in this case that we don't check for solubility exactly because it's very soluble. Are you following? What we'll do is that we'll check for evolution of gas. Evolution, a pungent gas. So in this case that they will tell you to apply mild heat to it, you will see that a effervescence will occur, a gas starts coming out. Exactly. Not a gas comes out, and that gas is irritating, pungent. Are you following? Good. Ammonia gas from what? Ammonium ion. Good. Take note of that. Ammonia gas from ammonium what? Ion. Then we have silver ion. If silver ion is in solution, what will be the color? Will be a brown precipitate. Okay? A brown precipitate. Insoluble. Sorry? That becomes what? Soluble in excess. Then the color will change to what? Colorless. Please observe this. Okay? For this ion, it is insoluble in drops. As you're dropping it, the precipitate is formed. But when you add in excess, it even decolorizes the brown from brown to what? Colorless. Exactly. And it now dissolves. Exactly. Now we have iron. Iron 2+. Iron 2+ is dirty green in color. Dirty green PPT. If you see it in solution, it is what? Dirty green. Now, if you allow this dirty green to stand for some minutes, it will change from dirty green to what? Brown. That's oxidation of occurred. Take note of that. So that's one of the ways to confirm that this ion is present in solution. Dirty green. It is insoluble in excess. It is insoluble in excess. Then ion 3, reddish brown precipitate. Take note of each of the colors of the precipitate. Reddish brown PPT, which is what? Insoluble in excess. So far so good. How many ions have we treated here? I think all the common ions have been treated. Copper, zinc, calcium, aluminum, lead, ammonium ion, silver ion, iron 2+, iron 3+. So these are the common ions that you're going to see in what? Qualitative what? Analysis. So using what? Sodium hydroxide, this is what you should expect. The next reagent that was provided was what? Aqueous ammonia, and that will be done in the next what? Video.